In this topic, we are going to discuss about types of optical fibers. So, based on the nature of the material, modes of propagation, and variation in refractive index of core fibers are classified into. That means we are grading the fibers depending upon the nature of the material, modes of propagation, variation in refractive indices, and both mode and refractive indices. So, depends upon the material, the nature of the material, it can be classified into glass fibers, plastic fibers, and depends upon the mode of propagation, it can be divided into single mode and multi-mode fibers. So depends upon the refractive index profile variation, so step index, graded index fibers, and both mode and refractive indices, that is classified as single mode stepped index, multi-mode stepped index, and multi-mode graded index. So let us see one by one. Now, what are the glass fibers? If the fibers are made by fusing mixtures of metal oxides and silica glasses, then these are known as glass fibers. So the most common material used in glass fiber is silica, that is oxide glasses. Example, germanium metal oxide mixed with silica glasses, we can manufacture the glass fibers. And plastic fibers, these are made up of plastics or of low cost and easy to maintain due to their toughness and durability. We already discussed that about strength, toughness, that is a tensile strength, like that. So example for plastic fibers is polystyrene mixed with methyl methacrylate. Okay, polystyrene, these are the examples for plastic fibers. Okay, so depends upon refractive index profile. The variation of refractive index of core with respect to fiber axis is known as refractive index profile. So depends upon the variation of refractive index of core with respect to the fiber axis is known as refractive index profile. That is, the refractive index of core is more than the refractive index of cladding. So based on this, you just go through the step index fiber and graded index fiber. Okay, so core, cladding. So see the difference between the step index fiber and graded index fiber based on refractive index profile. Okay, and next, based on variation of refractive index of core, optical fibers are classified into two types, that is step index fiber and graded index fiber. Based on modes of propagation of light rays, all these fibers are classified into two types, that is single mode fibers and multi-mode fibers. Mode means the number of paths available for light propagation in a fiber. That means how many light rays that can travel at a time through the core, that is depends upon the mode. Okay, so let us see step index fibers. In these fibers, the refractive index is uniform throughout the core of this fiber, and it undergoes a step change at the core cladding interface. So there is the refractive index change that varies step by step. So that is named as step index fibers. So we are discussing the refractive index at the core cladding interface because the reflection will take place at the core cladding interface. Okay, so based on the modes of propagation of light rays, step index fibers are classified into single mode step index fiber and multi-mode step index fibers. So see, single mode, that means only a single ray that can travel through the fiber. Multi-mode, so that is, that depends upon the diameter of the core also. So if the diameter is large, then more number of waves will propagate through the fiber. And next, single mode step index fiber, let us see. In this fibers, light propagates only in a single path. The core diameter of this fiber is about 8 to 10 micrometers, and outer diameter of cladding is 60 to 70 micrometers. Okay, so because of smaller diameter of core, there is only one path for the propagation. So that comes under single mode propagation. In this fibers, the transmission of light is by successive total internal reflections because there is no other ways to overlap. Okay, so lasers are used as light source in these fibers. So for these fibers, the laser source is taken as a light source. So these fibers are mainly used in submarine cable system. So one of the application of single mode step index fiber. Next, multi-mode step index fiber. So see how the diameter will be, how the refractive index will be. In this fiber, the core and cladding diameters are much larger to have many paths for light propagation. So here we are observing the number of waves will propagate through the fiber. So the core diameter of this fiber varies from 50 to 200 micrometers and the outer diameter of cladding varies from 100 to 250 micrometers. So light propagation in this fiber is by multiple total internal reflection, which is the principle behind the fibers. So it is used in data links which have lower bandwidth requirements. So we already discussed in the beginning of this chapter, it should have possess high bandwidth and should allow all frequencies of carrier waves. Okay. So now transmission of signals in multi-mode step index fibers. That means whenever the multiple rays traveling through this fiber, the concept of overlapping will rise. Let us see how it will be transmitted. So the signal is transmitted through the fiber in digital form. In these fibers, the light ray one, which makes greater angle with the fiber axis, suffers more reflections through the fiber and it makes more time to traverse the optical fiber. So whenever the angle of incidence is large according to the fiber axis, the reflections will more and it takes a lot of time to travel within the core. So whereas light too makes less angle with the axis, so the number of reflections will also less and it takes less time to reach the output, and that means end of the fiber. So at the output end we receive ray 2 first and later we get a ray 1 because the ray 1 will takes multiple reflections and the ray 2 is takes smaller, that means smaller reflections compared to the ray 1. So the ray 2 will reach the output. Okay, you can observe clearly here. Okay, so due to the path difference between the light rays, when they superimpose to form the output signals, the signals are overlapped in this because the overlapping concept rises. As we already said, there's a path difference between the light rays. When they are superimposed to form the output signals, the signals are overlapped. That means there is a cross connection, cross talk. In this we get signal distortion known as intermodal dispersion. That means the signals are disturbing. So if light 1 is carrying some information and light ray 2 that also carries some information, if those two are overlapped with each other, so there is a distortion, signal distortion, that is known as intermodal dispersion. So it is difficult to retrieve the information carried by the distorted output signal. Okay, so in this fiber the propagation of light ray is due to the multiple reflections, so it is reflective type. The number of possible propagation modes in the core is given by, so that is the radius r, radius of the core, and v 2 pi by lambda, that is a phase difference with respect to the radius of the core. Okay, and into NA, numerical aperture, that is the number of possible modes through the step index fiber is v square by 2, that is the velocity square by 2. Okay. And next, graded index fibers. In these fibers, the refractive index decreases continuously from center radially to the surface of the core. That means there is a variation. There's decrease in the order of from center to surface of the core, it will continuously decreases the refractive index. So the refractive index is maximum at the center and minimum at the surface of the core. So these fibers can be single mode or multi-mode. Okay, let us see how the multimode graded index fibers will be. That means the diameter of core varies from 50 to 200 micrometers and the outer diameter of cladding varies from 100 to 250 micrometers. So now the refractive index profile is circularly symmetric. That means it is varying continuously from the center to the core cladding interface. So that's why in this fibers the refractive index changes continuously radically in core. The light ray suffers continuous refractions in the core. So the propagation of light rays is not due to total internal reflections but by refraction. So that not takes a total internal reflection phenomena, but there is a refraction phenomena according to multimode graded index fibers. See, the path of the light rays will take place according to the continuous variation of refractive index from the center of the core to core cladding interface. Okay. See, in these fibers, the light rays travel at different speeds in different parts of the fiber. So, near the surface of the core, the refractive index is lower. So, the light rays near the outer surface travel faster than the rays travel at the center. So, here is a discussion which ray will traverse as first means near the surface of the core, the refractive index is lower, so the light rays near the outer surface travels faster than the rays travel at the center, that means center of the axis. Because of this, all the rays arrive at the receiving end of the fiber approximately at the same time. So there is a problem of intermodal dispersion can be reduced to a large extent using graded index fiber. So the number of possible propagation modes through graded index fibers is v square by 4. Okay, according to the previous phenomena, number of possible propagation modes through graded index fiber is v square by 4. Next, let us see what is the difference between step index and graded index fibers. So, first, step index fibers. So, refractive index of core is uniform and step or abrupt change in refractive index takes place at the interface of core and cladding in step index fibers. So, as well as in graded index fiber. Refractive index of core is non-uniform. So the refractive index of core decreases probably from the axis of the fiber to its surface. And now the light ray propagates in zigzag manner inside the core. The ray travels in the fibers as meridional rays and the cross the fiber axis for every reflection. Here the light rays propagate in the form of skew rays or helical rays. They will not cross the fiber axis. Okay. So signal distortion is more in case of high angle rays in multi-mode step index fiber. In single mode step index fiber there is no distortion. So if we are considering multi modes through the fiber, there is a chance of overlapping. It raises a signal distortion. So whenever we are using the single mode step index fiber, there is no distortion. Signals distortion is very low even though their rays travel with different speeds inside the fiber due to the helical structure of rays. Now the bandwidth is about 50 megahertz kilometer for multi-mode step index fiber, whereas it is more than 1000 megahertz kilometers in case of single mode step index fiber. So the bandwidth is lies between 200 to 600 megahertz per kilometer, even though they theoretically it has an infinite bandwidth. So we already discussed about bandwidth and frequencies. And attenuation of light rays is more in multi-mode step index fibers, but for single mode step index fibers it is very less. Attenuation of light rays is less in graded index fibers. So numerical aperture of multi-mode step index fiber is more whereas in single mode step index fibers is it very less. That means the light gathering capacity of multimode fibers is more compared to the single mode step index. So numerical aperture of graded index fibers is less. Okay, so these are the advantages and disadvantages and difference between the step index fibers and graded index fibers. Okay,